All right, welcome. Module 3, Task 8, to be determined. What you're doing here is you're given some information such as a table and a graph, and you're coming up with 3 different forms of ways to write the function. I'm going to start with number 3 here. This one lends itself pretty well to vertex form because we can see that the vertex here is right at -2, 0. Okay. It's also the x-intercept is also at -2, 0. And because it's quadratic, we know that there is multiplicity, meaning that it's x squared, so it's a multiplicity of 2 is another piece to look at here. But anyway, let's look at this. Let's say we wanted to do it with the vertex form. So the vertex form, again, the vertex form is a, that's a stretch, x minus h, that's the x value squared, and plus k, which is the y value. So looking at our vertex, we could say it's a times x minus -2, which is really x plus 2, and the k value is 0. So the only thing we're not sure here is what the stretch is, but if you look at it closely, like this is -1, this is -2, this is 1, this is 2, you can see that it goes over 1 and up 1, and that means that there is no stretch, or a equals 1. So therefore, the function is going to be x plus 2 squared. Now, factored form, I could write that as x plus 2 squared, or I could do something like x plus 2, that's my factored form. And my standard form, if you multiply these out, perhaps with FOIL, it would be x squared plus 4x plus 4. So there's essentially one x-intercept. It's used twice because it's x plus 2 quantities squared. Now let's look at this one over here. Again, they give us a table, and from the table we can be pretty confident on our vertex values here. We can see that the minimum value right here is -2 and 1. So that makes it fairly easy. The vertex is at -2, 1. And so our equation in vertex form is the stretch, which, by the way, on this one, instead of looking at the graph, let's look at the table. When you go up by 1 in x, y increases by 1. Or if you go back by 1, y increases in 1. And that's similar to 1 and 1 squared, so there's no stretch, right? So a equals 1. So now we can write our function x minus h, which is -2, so that would be x plus 2 squared, plus k, which is 1. Okay, so now that's our vertex form. Now, notice on this one, it's not going to have any x-intercepts, so we know we're going to need imaginary numbers, complex numbers, for our roots, solutions, and also for our factor form. So let's find these roots here. I probably would go to standard form next. I would expand this to x squared plus 4x plus 4 plus 1, and that would be x squared plus 4x plus 5. So my standard form f of x is x squared plus 4x plus 5. Now my factored form, I'm trying to find the roots. And for that, I'm going to use my vertex form, and I'll show you one way you can do it using that. Okay, so when I'm solving this, I'm setting this equal to 0 and seeing what values of x will make it 0. And in this case, I can subtract 1 from both sides. So it's equal to -1. And then I can take the square root of both of these. So the square root of x plus 2 squared is equal to the square root of negative 1. Now, the square root of negative 1, and we've already said is I when we looked at imaginary numbers. So now we've got x plus 2 is equal to I. If we subtract 2 on both sides, we've got I minus 2. Okay, and really it could be plus or minus I. So you could write it like this, plus or minus I. So plus or minus I minus 2. So our factor form, since those are the roots, is going to be x minus, let's say, plus I. So we'll say x minus I. And minus negative 2 would give us plus 2. Okay, so we've got, whoops, I lost it for a sec there. All right, and then the next factor, we would have x, this time let's use the negative I, so it would be x plus I, and it'd still be minus the negative 2, which would be plus 2, and so that represents our factored form.